Hello viewers, this is the video presentation for the subject Database Management System, and now we are going to see one topic, locking protocols, from the third unit. Before entering into the topic, we can see the objectives of studying this topic. To understand the concepts of lock, to identify the locking protocols, and to demonstrate the two-phase locking protocol. First, let us see about a lock. A lock is a variable associated with the data item that describes the status of the item with respect to possible operations that can be applied to it. Locking is an operation which secures permission to read, permission to write a data item for a transaction. So, lock have to be put on a data item. To access the data item may be accessed by the transaction either to read or to perform write. So based upon the operations, a lock have to be put on a data item. There are two functions are associated with the lock. Lock of X is the function. By executing this function, any transaction can put the lock on the data item X. So, data item X is locked in behalf of the requesting transaction. So, after using the data item by the transaction, it has to be unlocked. The unlocking is an operation which removes these permissions from the data item. For example, unlock of X is the function by which the data item X is made available to all other transactions. So, lock and unlock are atomic operations. Then there are some terms are there. First one is the lock manager module, which is the module which will manage the locks on the data items. And another one, data structure table, will be maintained by the database management system called as lock table, which is maintained by the lock manager, which is used to store some details about the transactions and the locks. For example, to store the identity of transaction, locking a data item and the particular data item and the mode of lock mode, and pointed to the next data item locked. So these things will be maintained in the lock table. And the one way of implementing the lock table is by using the linked list fashion. Next one is types of lock. The locks may be of two types, binary lock and read-write lock. Read lock is otherwise called as shared lock. Write lock is otherwise called as exclusive lock. Let us see about binary lock. Binary lock have two states or two values, zeros and 1. 0 means it denotes unlocked state. 1 means locked state. So if the lock state of one data item is 0 means the data item is free. That is, no transactions are currently using the data item. If it is 1 means it is locked state, that is, some transaction have put lock on the data item. So the lock value is 0 means then the data item can be accessed when request. When the lock value is 1 means the item cannot be accessed when request. Now we shall look at the small coding for the locking process. So lock item of X. So to lock an item X, before that a transaction will check the previous status of X by checking like this: if lock of X equal to 0. If lock of X equal to 0 means previously the item is in unlocked state, then only a transaction will execute the function lock of X. Then only the transaction can do the operation on the data item X. Else, the meaning of else here is, if the lock of X equal to 1, if the data item is previously in locked state, then the transaction have to wait until it becomes unlocked, until it becomes free. That is, until lock of x equal to 0, a transaction have to wait to put the lock on the data item so as to use the data item. Next one is unlock of item x. So after using the data item, after doing the necessary operation on the data item, the transaction will unlock the item by executing the function unlock of x. So to execute unlock of x, before that the status should be like this. Lock of x equal to, it should be 1. That is, if lock of x equal to 1, previously if it is locked state, then any transaction will execute unlock of x. Else, here the meaning of else is, if previously lock of x equal to 0, it will print like this. Print of, already it is in unlocked state. Now let us see the locking protocols. Before that, one more example we can see. One transaction is there. Transaction 2 wants to access the account A. To do, the transaction 2 is going to update some, do the updation on the item account A. So to access, before doing the operation, first it will lock the account A by executing the function lock of A. So after that it will read the account A, then it is changing the, it is reducing some amount 50 from the account A, then it is updating the value of amount of A to the database. So after doing the operations, it is executing the unlock function on A, thereby it is releasing the lock on A. It is executing, finally it is executing unlock of A. Next we shall move to read write lock. So first one is read lock. Read lock is otherwise called as shared mode lock. Here the thing is, multiple transactions can put read lock on a data item, and at a time multiple transactions can read a data item. So the read lock is called as shared lock. If a transaction TA has obtained a shared mode lock on item X, then TA can read the data item but cannot write the data item X. So outer transactions can also allow to read the data item but cannot write. Here is the coding for read lock of X. Read lock of X means one transaction is putting the read lock on the data item X. So before that, before putting any lock, the transaction will check the present status of the data item. So if it should be in an unlocked state. So if lock of X equal to unlocked, then the transaction will put the lock by executing the function lock of X. So here lock of X means one transaction is putting read lock. We have to assume it. Then after that, it is performing the read operation by executing the function read of X. Okay. So to read a data item X, what the transaction is doing? First it will check the previous status of the X. If it should be in an unlocked state, it will putting a lock on X, then it is reading X. Else if lock of X equal to read locked, if previously the X is read locked, then also the transaction can perform the read. Since the read lock only is available on a data item X, so another one transaction can also perform the read operation. So this new transaction is also perform the read operation by executing read of X. Else, after that the third else have the meaning, if write lock is available on the data item X, then the transaction have to wait until lock of X becomes unlocked. Okay, so the condition to read a data item is previously it should be in unlocked state or read locked state. If a data item is write locked state, then can't do anything. The transaction have to wait until lock of X equal to becomes unlocked. Then for the write operation, then to put the write lock. So for what a transaction will put a write lock? To perform the write operation on the data item X. So to put the write lock, a transaction first will check the status of X. That is, if lock of X equal to unlocked, then no problem. A transaction can put the first it will put the lock. That is, it will execute the lock of X. It is putting write lock on the data item X. Else if previously the lock of X equal to write locked, already if a data item is write locked, then can't do anything. Then the transaction have to wait until lock of X becomes unlocked. So it have to wait until the X will become unlocked state, then only it can put write lock, then only it can perform the write operation. Then else if lock of X equal to read lock, if it is read lock also, a transaction can't perform write operation. Then also if read lock also, it have to wait until unlocked from the read lock state. Then it is the coding for unlock of X. If lock of X equal to write locked, then any transaction have to put unlock. Else if lock of X equal to read locked, then any transaction can perform execute read of X. So if a data item is read lock state, any number of transaction can perform read operation. So after that, a transaction will execute unlock of X operation. Next, we can see the topic two-phase locking protocol. Two-phase locking protocol requires that each transaction issue lock and unlock request in two phases. They are growing phase and shrinking phase. Growing phase means during this phase means time instant, new locks can be occurred but none can be released. So growing phase is the time period during which all the transactions will occur the necessary locks on the data items. So the locks will be made on the different data items by the different transactions during the growing phase. Shrinking phase means after some time instance, after the usage of data items by the transactions will start releasing the locks. So the phase at which releasing the locks is called as shrinking locks. So during which existing locks can be released and no new locks can be occurred. So this two-phase locking protocol can be of two types: strict two-phase locking protocol and rigorous two-phase locking protocol. And now we can see the example for the transaction. So in this example, two transactions are there, transaction 1 and transaction 2. At time instant T1, transaction 1 is locking the data item A. At time 2, transaction T2 is locking the data item or account A. At time 3, transaction T1 locking B. And at time 5, transaction T1 is unlocking A. So these operations are performed. So here we can tell with the time instant, for the transaction T1, the steps 1 to 3 is called as growing phase, and for the transaction T1, the steps 5 to 7 can be called as a shrinking phase, since in the shrinking phase the transaction is releasing its lock. Similarly, from the steps 2 to 6, the transaction T2 is doing the locks, putting the lock. This is called as the growing phase of transaction T2. And last step number 8 to 9, the transaction T2 is releasing the locks. So this time period or these steps are called as the shrinking phase of the transaction T2. And now lock point. The lock point is the point at which the growing phase ends. That is, when the transaction takes the final lock is need to carry on its work. So the point at which the growing phase ends is called as lock point. Also, we can see the growing phase and shrinking phase with this diagram. Here, at the time T1, T2, T3, T4, throughout this time periods, various transactions are putting the locks on various data items. So this time period, that is the time period from T1 to T4, is called as growing phase. After that, from the time period 4 to 5, all the transactions will doing the operations on the data items. This time period is called as locked phase. After that, after the time period 5, all the transactions will the transactions may complete the operations on the data items, and one by one transactions will start releasing the locks. So this time period, from the time period from 5 to 5, 6, 7, 8, these time periods are called as shrinking phase. Now, strict two-phase locking protocol means this protocol requires not only the locking be two-phase, but also it all exclusive locks taken by a transaction be held until the transaction commits. Rigorous two-phase locking protocol means this protocol requires that all locks be held until all transaction commits. Next, there are some processes are called lock conversion. Two lock conversions may be possible: lock upgrade and lock downgrade. Lock upgrade means converting from the read lock to write lock. So this can be possible only at the growing phase. So if TI has a read lock and TJ has no read lock on a data item, then convert the read lock to write lock, else force the TI to wait until TJ unlocks X. So if a transaction having a read lock on a data item X, and if another one transaction having no read lock on a data item X, means then a transaction TI can convert its read lock on the data item X into write lock, since no other data transaction is using the same data item. So if it is using by some other data item, some other transaction, then one transaction, for example TI, have to wait until the another transaction TJ unlocks the data item X. Lock downgrade. It is the process of converting the existing write lock into read lock. This is happening only in the shrinking phase. So to convert the write lock into read lock, there is no problem. No transaction since one data item having write lock means no other transaction may have the lock on it. So any transaction can easily convert the write lock into read lock. Next thing is log. Log is a history of actions recorded by the database management system. It will record the history of actions executed by the database system. The things will be recorded to recover the operations if in any case of failures, such as hardware failures or any software crashes. So a log is a file of updates done to the database stored in stable storage. A log records for a given database update must be physically written to the log before the update physically written to the database. All other log record for a given transaction must be physically written to the log before the commit log record for the transaction is physically written to the log. So these two are two rules about the log maintenance. Commit processing for a given transaction must not complete until the commit log record for the transaction is physically written to the log. Now let us see some process of database management system associated with the log maintenance. So the transaction manager module is there. The transaction manager module is maintaining the log record. All the database operations executed by the transactions like read write operations are handled by the transaction manager, and the scheduler is the module which will schedule or rearrange the transaction operations, and all the lock informations are maintained by the scheduler in the lock table, and the different transaction operations are stored in the intermediate buffers. Now let us see one example for the system log. A transaction is start its operation. It is writing the data item. It writing the new value by replacing the old value, and read the data item. The transaction commits, the transaction aborts. So when a transaction aborts, the operations will be recorded into the system log. So in the two-phase locking protocol, now we are going to see the operations happen in the phase 1 and phase 2 of the protocol operation. The phase 1 is called as obtaining a decision step. So in phase 1, a decision will be taken by the modules. This is also called as a prepare step. So in phase 1, the coordinator will ask all the participants to prepare to commit the transaction. So the coordinator CA adds a record or a message prepare to the log and forces the log to stable storage, and it will send the prepare T message to all the sites at which T is executed. So at once upon receiving the message, the transaction manager at site determines if it can commit the transaction. If not, if the transaction cannot be committed, it will add a record no T to the log and send abort T message to CA. If the transaction can be committed, then add the record ready T to the log and force all the records for T to stable storage. Send ready T message to the coordinator CA. In the phase 2, after taking the decision, that is, the decision will be taken in the phase 1 whether the transaction can be committed or not. In the phase 2, the decision will be implemented, that is recording the decision. Commit operation, actual commit operation will be happens in the phase 2. T can be committed if CA received a ready T message from all the participating sites, otherwise T must be aborted. So coordinator adds a decision record commit T or abort T to the log and forces record onto the stable storage. Once the record stable storage, it is irrevocable. So coordinator sends a message to each participant informing it about the decision. So participants take the appropriate actions locally. So now let us see about the operations will be performed if the failures, like first one is site failure. So how the transactions will handle the site failure. So when a site SI recovers, after the failure, when the site recovers, it examines its log to determine the fate of transaction active at the time of failure. Okay, so it will do the necessary operations after the recovery from the failure. It will check the log. If the log contains commit T record, then site executes the redo of T operation. If the log contains abort T message record, it will execute undo of T operation. If the log contains ready T record, the site must consult the coordinator, then only it can determine about the fate of the transaction. If T committed, it will execute redo of T operation. If T have to be aborted, it will execute undo of T operation. The log contains no control records concerning T replies that the site failed before responding to the prepare T message from the coordinator. So since the failure of site includes the sending of such a response, CA must abort T. So next one is handling of failure, coordinator failure. So if the coordinator fails while a commit protocol is executing, then the participating sites must decide about the transaction's fate, whether have to commit a transaction or to abort a transaction. So if an active site contains a committee record in its log, then T must be committed. If an active site contains an abortee record in its log, then T must be aborted. So if some active participating site does not contain a ready T record in its log, then failed coordinator cannot have decided to commit T, then therefore the transaction will be aborted. If none of the above cases holds, then all the active sites must have a ready T record in their logs, but no additional control record is present. In such cases, active sites must wait for the coordinator to recover and to find a decision. Next one is handling of failures after a network partition. If the coordinator and all participants remain in one partition, then the failure has no effect on the commit protocol. If the coordinator and its participants belong to the several partitions, then the sites that are not in the partition containing the coordinator think that the coordinator has failed and execute the protocol to deal with failure of the coordinator. It will create no harm results. If the coordinator and the sites are in same partition as the coordinator think that the sites in the other partition have failed, and it will follow the usual commit protocol. Again, it leads to no harmful results. Next is, at last we can see the possible university questions. The first question may be discuss on two-phase locking protocol. Second question is explain how the failure conditions can be handled, such as site failure, coordinator failure and network failure. Okay. Thank you.